Hey, welcome back. So, now we come to probably the biggest selling point at the time the Commodore 64 arrived in 1982. That was its enormous memory, the 64 kilobyte of memory. So, that's what you have to look at right now. So, the way we do that is by looking at how we need to look at it as programmers. So 64 kilobyte, that's over 65,000 bytes. What I have done here is I have segmented it into 4 kilobyte segments. So I divided it like this. And another thing, when we're talking about memory addresses, we usually use the hexadecimal format. Now, like I mentioned last time, when we use hexadecimal numbers, we use a $sign in front of them. And we will be looking at numbering systems really soon. But anyway, here's our Commodore 64 memory. And like I said, I divided it into 4 kilobyte segments. So we start our memory at address 0000, and it goes all the way up to FFFF. Again, these are hexadecimal numbers. So like we briefly looked at last time, the RAM is just like a huge table. Think of it that way, with over 65,000 cells. And in each of those cells, we can have 1 byte. So, what we're looking at here is the entire memory, starting at 000, going all the way up to FFFF here at the end. So, and again, let's not forget that 1 kilobyte is 1024 bytes. That will be important to remember. So 64 kilobytes, that's 65,536 bytes. Alright, however, when you start up the Commodore 64, you can't use the entire memory. Because when you start your Commodore 64, your memory looks like this. So all the green areas, that's free RAM. That's available RAM. So we have this segment right here, and there's a little segment here. So not all of the Commodore 64 memory is free or available when you start up the Commodore 64. Now the reason for that is that some things are automatically loaded in to memory when we start our Commodore 64. And one of those things is the basic RAM. That's this part right here. So the basic RAM, that's the thing that almost the operating system almost. So it's the first thing you see when you turn on your Commodore 64. And it's the thing that allows you to program in the basic programming language. So it takes a decent chunk of memory, basic here. Now, when we are programming in assembly language, we can in fact disable this if we don't need basic for our program. But we will not be doing that. We will be taking a look at how we can do that, but we won't be using this address. And we'll be coming back to that later. But let's continue looking at the memory. So there's a pretty huge area here at the end that's also occupied from the start. Now, one of these segments I've just called IO++. So this is input, output, and all kinds of things. And, well, we will look at this in detail, but how we control our sprites, those kinds of things are also in here. And lastly, we have something called the kernel RAM. And again, like I said with the basic, this is also kind of the operating system. So the kernel RAM and basic, Those are the things that make you makes the Commodore 64 easy to use when you turn it on. But all of this can be disabled when we get really good and we know how to use this area. But by default, we in this course will only be using this area here. This area right here. So from around 0800, memory address 0800, and all the way up to 1000. So when you turn on your Commodore 64, you see this screen, and it says it's a 64K RAM system, so 64 kilobyte RAM system. Then it says 38,911 basic bytes free. So it actually says right here that not all of the RAM is available to you as a user. 38,911 bytes. So why exactly that number? Well, that's actually the area that we just looked at. So let's look at it again. This area right here, that's 38,911 bytes. And the reason for it, the reason we don't have this as well is because BASIC need a contiguous area. So we can't have this and then a little break here and then continue on here. BASIC needs this contiguous area right here. So it's not we don't need to worry too much about that right now as beginners, because when we're programming in assembly language, almost 39 kilobytes, that's a decent chunk of memory. We can cram a lot of sprites, a lot of code, a lot of music, tables, whatever in here. So we don't need to worry too much about the lack of memory space. Alright, so why this number? Well, let's take a look at our calculator here. So I'm gonna set it in hexadecimal mode, like that. And I'm gonna write the memory address 8000. That's the top of the free memory area that we just looked at. And I'm going to subtract 800 in hexadecimal. Now that's because from 000 memory address 000 all the way up to memory address 800, we're not going to be using that very much, and we'll take a look at that later. But that area is off limits as well. So if we subtract 800 in hexadecimal, we end up with this number, 9,800 in hexadecimal. But if we convert it to decimal, the normal decimal system that we use, we end up with this number, 38,912. Don't worry about the extra number here. So 38,912, that's basically the same number that we just saw. 38,911. Now the reason that we have one more here is that when we're working with code like this, we start counting from 0. So 0, 1, 2, 3. So that's why we have an extra number here. But the point here is that that's how we know what we're dealing with. This area is 38,911 bytes. So I said that for each memory cell, each memory address in the Commodore 64 RAM, we can have 1 byte. So if you take a look at this segment now, from 0000. So as I said, we don't count from 0 to 1000 to 2000 like it says up here. That's just the way I divided it up. But if we look at actual memory, how we need to think about it, it's like this down here. So we start at 0000 and then 0, 0, 1, 2, 3, 4, 5, and so on. And it goes on like that, as I said, all the way up to F, 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 which is the very last memory address. And like I said, we can have 1 byte in each of the memory addresses. So for example, what's a byte? Well, we briefly mentioned that last time. An 8-bit byte that we need to use, that's a number from 0 to 255. So any number between 0 and any number between 0 and 255. So that means that, let's say the first memory address here, maybe I have a 0 in here. The second one I have 53. Next one I have 255, and 1, 70, 75, 22, so on. You get the idea, right? So every single memory address of the Commodore 64 contains 1 byte. It contains a number between 0 and 255. That's all the memory, that's all the RAM is really. It's just a huge table with over 65,000 numbers, like this. So that might seem strange, because especially if you haven't done any programming before, you might be thinking like, well, where does the graphics come from? How can we do this and that? Well, here's the thing. Everything is basically just numbers. So it might get a little getting used to, especially if you haven't done any programming before. But for now, we just need to remember that every single memory address in the Commodore 64 contains 1 byte, a number between 0 and 255. So let's end today's video by taking a look at how we do this in assembly language. So again, we just briefly saw this last time, but we haven't really talked about assembly language itself. So this is just an example. But the way we would load something and store it into memory, we already looked at it last time, but let's repeat it. So I'm going to load 5 into the accumulator, the part of the CPU that can hold a number. So I'm going to say LDA to load the accumulator, space, hashtag, and the number 5. So now I'm loading the number 5 into the accumulator. And remember, it could be any number between 0 and 255. So I could load, let's say 127 in here as well. So it doesn't really matter. It's just an example, but I'm going to load 5 into the accumulator. Then, after that, right now the number 5 is inside the accumulator, and the accumulator is in the CPU. So right now, the number is inside the CPU. So that's no good. We need to put it somewhere. So let's put that in memory address 4000. So load accumulator, LDA, store what's in the accumulator, that's STA. And I just said I want to store this in memory address 4000. Now 4000, that's just a random address that I thought of right now. So STA for 4000. All right. So right now my assembly program loads the number 5 into the CPU, the accumulator in the CPU. After that, it stores whatever is inside the accumulator. It stores that number in memory address 4000. Alright, so this is the very basics of assembly language, but this is we're going to do this all the time, loading and storing, loading and storing. So we're gonna see LDA, STA a lot. But hopefully you have some understanding of the Commodore 64 memory right now. And next time we will be looking at variables, constants, and some other small things that we need before we actually get started programming. So that's it for today. Bye bye.